Hello, this is Miss Poor, and this is going to be a recording of today's live CC that didn't happen because we had Blackboard issues. So let's go ahead and get started. I'm going to give you a couple of minutes to go through and answer these warm-up questions. The first one is blank points are points that lie on the same line. What kind of points are those that lie on the same line? Number 2 is blank points are points that lie in the same plane. What kind of points lie in the same plane? And then the third question is the sum of the measures of two blank angles is 90 degrees. So, what special pair of angles will have the sum of 90 degrees? Okay, go ahead and let you know what these answers are for these. This first blank is going to be collinear. Collinear points are points that lie on the same line. The answer to number 2 is coplanar. Coplanar points are points that lie in the same plane. And then the sum of the measures of two complementary angles is 90 degrees. Alright, let's go ahead and get started with our new unit, which is Unit 2. And the first thing we're going to discuss is inductive reasoning. Before I get into the definition of deductive reasoning, I just wanted to go over some examples with you. It says find the next item in the pattern. And you see it's January, March, May. So what do you think the next month would be? I'm going to throw this out there that it could be June. I almost wrote July. So how did you determine that pattern? So in my head when I was saying it, I'm so used to saying the months in order, it's kind of hard not to. So if you look, January, February, March, oh, I should have wrote July. Now that I've started writing this out. So January, February, March, April, May, and then, no, I did it right. Then you would have had June. Oh, no, I didn't. And then there's July. Okay. So they skipped June. The answer should have been July. Alright. My brain wasn't working right. Y'all know me on this early. 11 a.m. is early in the morning, huh? When I'm working in the morning like this, even after I've had my coffee, it takes a time for all the cobwebs to clear out from the night before. So, as you can see, I went ahead and wrote up there the missing months. So it looks like it was alternating months. Now on this next slide, I'll just show you what the official answer says. It was correct that the next month is July, and alternating months of the year make up the pattern. Okay. Look at this pattern. It says find the next item. You got 7, 14, 21, and 28. So I'm going to give you just a second to think about what the next number is going to be. I'm going to think that the next number is going to be the number 35. Hope my multiplication's working well at this early in the morning. So if I look, this is 7 times 1. This number is 7 times 2. This one is 7 times 3. This one is 7 times 4. So it would seem natural that the next number in the pattern would be 7 times 5. And how did we determine the pattern? Well, it looks like this was multiples of 7. Let's see what the official answer says. Miss Poor is waking up yet. Okay, did good. Multiples of 7 make up the pattern, so the next multiple would be 35. One more example. Find the next item in the pattern. Oh, wow. Well, this one, we have to start thinking about what we learned in Unit 1 about transformations, and it looks like this one could be a rotation. So if we look, it looks like this is a rotation of 90 degrees from that triangle. Then it looks like this triangle is also a rotation of 90 degrees based on the position of this triangle. So if I was to take this last triangle and rotate it 90 degrees, again, I bet it would look something like that. So you would put down here for how you determined that rotation of 90 degrees for each triangle. Well, I bet the official answer sounds better than that. Let's see what it says. In this pattern, the figure rotates 90 degrees, counterclockwise each time. I guess I should have noted that it was counterclockwise, and it looks like I did figure out the next figure. So at least I did that right. Alright, so here we're going to talk about what inductive reasoning is. When several examples form a pattern and you assume, we don't like that word assume. Okay, it's not a good word. We assume the pattern will continue. You're applying inductive reasoning. And in geometry, we do not assume. We do not make assumptions. We use a different kind of reasoning. And we'll talk about that in just a moment. But let's finish up with our discussion of inductive reasoning. Inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. You may use inductive reasoning to draw a conclusion from a pattern. And just so you understand that when you're using deductive reasoning, you're drawing a general conclusion from specific observations, experiments, or measurements. A statement you believe to be true based on inductive reasoning is called a conjecture. Now then, the kind of reasoning that we use in geometry is called deductive reasoning. We always use facts, rules, definitions, or properties to reach logical conclusions. It's very important not to assume anything more than what is exactly written. And I'm going to add to this, I'm going to say, or shown in a figure. So if you see something that looks like this, we don't assume those are right angles. Never, never, never. Okay? Because their measure might be 89.9 degrees, and that is not a right angle. However, if you have a figure that has that little box, you don't have to assume anything. You know that's a right angle. So never ever assume in geometry. Only go with what is given. So deductive reasoning is the process of using logic to draw conclusions from given facts, definitions, and properties. And just an FYI, when we talk about given facts, that's what's given in the problems, just like I showed you. And let me add to this, we do use definitions and properties, but in geometry, I was looking for another word to tie this into, but it's not there. We use postulates and theorems in addition to the definitions and properties. Deductive reasoning is a type of reasoning that uses previously proven or accepted properties to reach conclusions. It is also drawing a specific conclusion from general observations, experiences, experiments, or measurements. I don't like those words there. I think I copied and pasted and forgot to take those out. So I'm taking them out now. Ignore that. But you are drawing specific conclusion from general observations. Deductive reasoning is used in mathematical proofs, which is why I said we only use it in, well, we don't only use it in geometry. It's why geometry only uses deductive reasoning. And it's a valid way to draw conclusions in mathematics. And I'm going to give you some examples of deductive reasoning. A mechanic uses it to determine what's wrong with your car. A doctor uses deductive reasoning to diagnose a patient, and we're very glad of that. Our goodness gracious. You know, it seems like every medication commercial that we see on TV, they give us all the list of the effects that it could have on a person. Well, a lot of medicines all have those same effects. In the same way, a lot of illnesses have the same effects. So therefore, we wouldn't want a doctor just to look at our symptoms and use inductive reasoning to decide what's wrong with this. We may end up going back several times before he finally finds a cure. So we always want our doctors to use deductive reasoning. Another example is a lawyer, and I always tell students when we're getting ready to do proofs later in Unit 2 is that just think of yourself as a lawyer defending your case, and there can't be any loopholes. Okay, so lawyers also use deductive reasoning. And of course, a detective uses deductive reasoning to solve crimes. Now, there are two laws used in logical reasoning. We have the law of detachment and the law of syllogism. The law of detachment says, hey, if A is true, wait, no, you say, if A, then B, therefore B is true. I guess I should read what I've written. Okay, so you're saying A, then B. Well, if A is true, then B has to be true. So here's some examples of the law of detachment, and let me show you how we work these out. We say if Joe is a student at K-12 Texas, then Joe has an ID number. Joe is a student at K-12 Texas. Okay, with our conclusion, let me make some notes up here to show you how this works. If I said, for the law of detachment, you're going to say, if A, then B. If A is true, B is true. Let me show you what A, B, and C are. Joe is a student at K-12 Texas. That's A. Joe has an ID number. I'm going to put that right there. This would be B. Joe is a student at K-12 Texas. Well, that's A. And we're going to say that's true. So I've identified A. A is that Joe is a student at K-12 Texas. In the phrase, I've identified part B, which is Joe has an ID number. Then what is done is says Joe is a student at K-12 Texas. That's just repeating phrase A. Therefore, and this is the symbol for therefore, those three little dots, B is true. So my conclusion is going to be that Joe has an ID number. Now let's see what my official answer says here. There you go. That's how I wrote it out to kind of help you better understand how this law of detachment is working. So you have if A, and remember I said A is Joe is a student at K-12 Texas. Then B, and the B phrase is Joe has an ID number. So if A is true, then B is going to have to be true. So my conclusion is that Joe is a student at K-12 Texas. And up here we did say that A was true. Let's look at this example. I'm going to give you just a moment to work through this one on your own. Okay, if you need longer, just press the pause button. Alright, I'm going to go ahead and go through this. I'm looking at this, and if you notice, when I'm looking at these to figure out what part is A and what part is B, notice that if it's after the if, that's a big one, I'm calling it A. If it's after the word then, I'm calling that part B. Alright, so it says for part A, and remember what we're doing here, if A then B, A is true, oops, therefore B is true. So if you look right here, this second sentence is just repeating A. But why it's repeating A is it's letting us know A is true. Oops, I cannot write the word true. So we know if A is true, therefore B is true. So my conclusion is going to be that Jamie is in the top 10% of her class. Okay, so let's see the official answer. It says, like I said, the A phrase, you plan on attending the University of Texas. Then B is you need to be in the top 10% of your class. Remember, right here in the second sentence, they're letting us know that part A is true because Jamie is planning on attending the University of Texas. So here is our conclusion, that B must also be true. Jamie plans on attending the University of Texas, and Miss Poor put these slides together too quick. The conclusion, I'm going to do this arrow right up here is just like I said on the previous slide. Jamie is in top 10%. Which I think that's been lowered to 5% for UT, but I'm not positive. Sorry if that confused you, because I accidentally put the wrong phrase in there. Okay, let's look at this example. This will be our last example of the law of detachment. It says, if a dog eats dog food delights, then the dog is happy. Fido is a happy dog. Okay, so if we look right here, a dog eats dog food delights. That's A. Right here is phrase B. Remember, because we're going to A, this arrow right here represents the word then. If A, then B, actually it means implies, but I'm using the word then. A implies B. Okay, so A has to be true for B to be true. Okay? So this phrase right here, Fido is a happy dog, if you look at it, all that's doing is saying B is true. It's not telling us that Fido eats dog food delights. It's telling us that Fido is a happy dog. So, no conclusion. Alright, there's no conclusion, because remember, if it's A implies B, A must be true for B to be true. In this example, it's saying A implies B, B is true, oops, so no conclusion. Because we don't know if Fido may be eating another brand of dog food and he's quite happy with it. He may not be eating dog food delights. Okay, there we go. And I just wrote this one out on purpose, like, well, this one right here. Therefore B is true. See how I put then B? If A, then B is true. It's still no conclusion, because like I said, we have no idea. Oops, I guess I'm leaving out words. Have no idea what Fido is eating. No conclusion. But I wanted just to show you how A has to be right here and it has to be true in order for B to be true. Okay, the law of syllogism says, hey, A implies B, B implies C are both true statements. Then A implies C is a true statement. And I bet y'all are going, what? What is that saying? So the best way to learn all this letter jibber jabber is to actually work some examples. It says, if you were born in Mexico, then you were born in North America. If you were born in North America, then you were born in the Western Hemisphere. So let's look at the way this works. Remember A, let me write this up here. A implies B, B implies C, therefore A implies C. So all we do is rewrite these sentences, okay? So here's A, then you were born in North America is B, you were born in North America again is going to be B, then you were born in the Western Hemisphere is C. So what you do now that you've identified what A, B, and C phrases are, you're going to take those two phrases, put them together to form your conclusion. So after reading this sentence, we can say, oh, okay, well, A says, if you were born in Mexico, now our then is going to be the C part. Then you were born in the Western Hemisphere. All right, so that's our conclusion. All we had to do was take those statements that we identified and put them together. So if A implies B and B implies C, therefore A also implies C. Let's work another example. Okay, this one I'm just going to give you a couple minutes. Well, not even a couple minutes. I'm going to give you a minute to identify the phrases and put together a conclusion. Okay, now if you need some more time, go ahead and push the pause button, because I'm giving you a spoiler alert. I'm going to go through the answers. If you drive a car, then you have a license. If you have a license, then you passed your driver's test. And we've got to figure out what is phrase A, what is phrase B, what is phrase C, and draw a conclusion. So remember, A implies B, B implies C, therefore A will imply C. So you drive a car, that's your A phrase. Then you have a license, that's your B phrase. If you have a license, that's also B. Then you passed your driver's test, which is C. So let's put A and C together, and that will be our conclusion. If you drive a car, then you passed your driver's test. And I bet many of you will be doing that soon. But that's going to be your conclusion right there. All right, here's another example. And I'm going to give you just a moment before I give the spoiler alert. All right, if you need a little bit more time, please go ahead and press the pause button. The first phrase, A, then they do not form a linear pair, is B. If two angles are vertical, is A. Then they are congruent, is C. Okay, let's think about it. Remember, A implies B, B has to imply C, therefore A implies C. So on this one, there's no conclusion. Let's talk about why. This phrase right here has to be the be phrase, okay? Where it says right here, B implies C. Well, in our second sentence here, we've got A implies C. That can't work. All right, we went right from A implies B to A implies C. We've got to have the B implies C for A implies C to be true. Okay, so really we're not given enough information. They gave us the beginning phrase or the beginning sentence and the conclusion, but they didn't give us more information to determine the conclusion. And I did give you an example right here. I showed how A implies B. Well, if B implies C, right here it says if two angles are vertical. Okay, that's not a be phrase. That should say they do not form a linear pair. All right, so that's why I have that highlighted in green, because I wanted you to see, ooh, that's not working. Okay, our attendance quiz is going to be a little bit different today. I've actually included it in the slides, so that way you can go ahead and take it. So the quiz has not been transferred to you because I can't transfer it to you in a recording. Remember, if it was mandatory that you attend today, you have to take the attendance quiz because it's 10% of your course grade. If you listened to the recording but you were told you were exempt from the attendance quiz, you may now stop the recording and enjoy the rest of your day. All right, for those who do have to take the quiz, let me see. We don't have to worry about this part. Boop. It's not being transferred to you. It's not optional. How to take the quiz. Don't worry about this part. But I'm going to go through the slides, and if I move too quickly, just press pause. And you will just sit there and look at the question and answer it. Okay, don't worry about how fast I'm going through the questions. Just press pause. Okay, so you're going to go through this recording. You're going to document your answers. You're going to go to the Geometry LMS, and you're going to do just like we've been doing for the last 4 weeks. You're going to scroll down to the bottom, and then you're going to click on the Week 5 September 24th attendance quiz, and then you're going to enter all your answers. I'm going to give you a warning. If you go through there and you don't give me answers and you just enter the password, I will see it. You will get a 0. Okay, so don't do that. I want you to honestly go through and try to answer these questions. And what this does is it lets me know what we need to study more. So unless you want to study it some more, give me an answer. All right, let's go to the first question. And I'm probably going to leave it up for about 15 seconds, and then I'm going to go to the next question. So remember, if you can't answer it in 15 seconds, then press pause. All right, the password for today, and be sure you enter it in all lowercase. Thanks for listening, and let's hope Blackboard is up and running. If you need to come to office hours in the morning at 8, or you can come to tutoring tomorrow at 3. Missed seeing y'all in live session. We'll talk to you later. Bye-bye.